There is a moment that many people recognize but few talk about openly. It happens somewhere in your 40s or 50s, sometimes earlier, sometimes later, but when it arrives, it is unmistakable. It begins as a faint tingling in your lower back after sitting too long, or a dull, persistent ache that radiates down one leg and refuses to fully disappear, or that strange electrical sensation in your fingers that comes without warning and leaves without explanation, or the feeling that your spine, that central column of structure and sensation that has carried you through every experience of your life, is no longer as reliable as it once was. Most people respond to these signals with a quiet resignation. They adjust their posture, they buy a new mattress. They take an anti-inflammatory for a few days and wait for the discomfort to pass. And when it returns, they begin to accept that this is simply what aging feels like. Today I want to offer you a different framework. Not a false promise, not a miracle cure, but a scientifically grounded, biologically coherent explanation for why nerve damage and spinal discomfort develop, and why a fruit most walk past may be the most powerful tool for reversing that process. That fruit, the one that most walk past, is the pomegranate. What we know about pomegranate and the nervous system has changed dramatically. Research has identified compounds that cross the blood-brain barrier and penetrate nerve tissue. These compounds reduce inflammation, stimulate the regeneration of myelin, the protective sheath around nerve fibers, and promote the growth of new neural connections. None of this was well understood 20 years ago. Much of it is still not part of mainstream conversations, but it is real, it is documented, and it matters profoundly. In this video, we are going to cover all of it. We'll start with the spine itself, what it is, and why it becomes vulnerable with age. Then we'll go deep into the science of nerve repair. Then we'll walk through exactly how pomegranate intervenes in that biology. And finally, we'll talk about how to use this fruit effectively and what changes you can make this week. Let us now begin the in-depth look at our nervous system. Your spine is not simply a structural column. It is a living, dynamic communication highway. Running through its center is the spinal cord, a bundle of hundreds of millions of nerve fibers that carries every signal your brain sends to your body and every signal your body sends back to your brain. Every sensation you feel, every movement you make, every reflexive response your body produces without conscious thought, all of it depends on the integrity of the nerves that travel through and branch out from your spine. Along the length of the spinal column, 31 pairs of spinal nerves exit through small openings between the vertebrae. These nerves serve every region of the body: the shoulders, the arms, the chest, the abdomen, the hips, the legs, the feet. When those openings narrow, due to disc degeneration, bone spur formation, inflammation, or loss of disc height, the nerves that pass through them become compressed. Compressed nerves cannot transmit signals properly. The result is pain, numbness, tingling, weakness, or burning sensations in the areas those nerves serve. This process doesn't happen overnight. It accumulates over years, quietly, through a combination of mechanical stress, inflammatory damage, oxidative injury, and the progressive degradation of the protective tissue surrounding the nerve fibers themselves. Understanding this progression is not depressing, it is empowering. Because when you understand the mechanism of damage, you can understand the mechanism of repair, and that is where the conversation becomes genuinely hopeful. Most people think of nerve damage as a single event, a herniated disc that presses on a nerve, or a traumatic injury that severs it. And while those acute forms of nerve injury certainly exist, the far more common pattern in people over 40 is a slower, layered form of neural degradation. The first is myelin breakdown. Myelin is the fatty, protein-rich sheath that wraps around nerve fibers the way insulation wraps around an electrical wire. Its function is identical to that insulation. It prevents signals from leaking out, allows them to travel at high speed, and protects the nerve fiber. When myelin degrades due to inflammation or oxidative stress, nerve signals become slower, weaker, and less precise. The tingling, numbness, and burning that so many people experience are often the direct sensory experience of demyelination. The second layer is neuroinflammation. When nerve tissue is under chronic stress, the immune cells called microglia and astrocytes become hyperactivated. In acute injury, this inflammatory response is protective. It clears damaged cellular debris and initiates repair. But when the triggering stress is chronic rather than acute, the inflammatory response becomes self-sustaining. It produces a cascade of pro-inflammatory molecules, cytokines, and reactive oxygen species that damage healthy nerve tissue. Neuroinflammation doesn't just impair healing, it actively extends the damage. The third layer is mitochondrial dysfunction. Neurons are among the most metabolically demanding cells in the body. They require an abundant supply of cellular energy to maintain their electrical gradients and generate the chemical signals of neurotransmission. When nerve cell mitochondria are impaired by oxidative damage or nutrient deficiency, neurons begin to function erratically and eventually undergo a process of degeneration called apoptosis. These three layers, myelin breakdown, neuroinflammation, and mitochondrial dysfunction, reinforce each other in a cascade that progresses steadily. But each of them can be interrupted, and the pomegranate contains compounds that address all three through distinct biochemical pathways. Spinal nerve vulnerability increases with age for several converging reasons. The intervertebral discs, the cartilaginous cushions between vertebrae, lose water content and elasticity progressively after age 30. By 50, most adults have measurable disc dehydration. As discs thin, the spaces through which nerve roots exit the spine narrow, increasing compression risk. Simultaneously, the body's antioxidant capacity declines with age. The enzymes responsible for neutralizing reactive oxygen species become less efficient. Oxidative stress accumulates faster than it is cleared. Nerve tissue, which is particularly rich in polyunsaturated fats and therefore vulnerable to oxidative damage, bears a disproportionate share of that burden. Additionally, levels of neurotrophic factors, the proteins that promote nerve survival and repair, including BDNF and NGF, decline with age. Without adequate neurotrophic support, damaged nerve fibers lack the biological signals they need to initiate the repair process. The convergence of these factors creates the conditions for the spinal nerve decline that so many people in midlife experience. The pomegranate has been cultivated for more than 4,000 years across the Mediterranean, Middle East, and South Asia. Modern nutritional science initially focused on its antioxidant content, specifically the polyphenols responsible for its deep red color. But the most significant discoveries have come from what happens to pomegranate's compounds after they are digested. When you eat pomegranate, its primary polyphenols, punicolagens, travel through the digestive tract and are metabolized by gut bacteria into urolithins. Urolithins, particularly urolithin A, appear to cross the blood-brain barrier, penetrate nerve tissue, and interact with the machinery responsible for repair. The gut microbiome plays a decisive role here. Not everyone converts punicolagens to urolithins with equal efficiency. Pomegranate's profile extends beyond urolithins. It contains ellagic acid and punicic acid, a rare omega-5 fatty acid with anti-inflammatory properties. It also contains anthocyanins that modulate neuroinflammatory pathways and vitamins and minerals essential for myelin synthesis. Each of these acts through a distinct mechanism. Together, they create a synergistic profile that no single synthetic compound has yet replicated. Let's begin with perhaps the most extraordinary mechanism in pomegranate's neural repair profile. Every cell in your body, including every neuron in your spinal cord and peripheral nervous system, contains mitochondria that eventually become damaged, dysfunctional, and unable to produce energy efficiently. Under normal, healthy conditions, the body has a process for identifying and clearing these damaged mitochondria called mitophagy, a form of cellular housekeeping that removes defective energy producers and replaces them with new, functional ones. In aged and chronically stressed neurons, this mitophagy process becomes impaired. Damaged mitochondria accumulate inside nerve cells. They cannot produce adequate ATP. They generate excessive reactive oxygen species. They trigger the cellular stress pathways that ultimately lead to neurodegeneration. And because the mitophagy system is impaired, the debris is never cleared, and the dysfunction becomes self-perpetuating. Urolithin A, the metabolite that gut bacteria produce from pomegranate's punicolagens, has been identified in peer-reviewed research as a potent activator of mitophagy. A landmark 2016 study published in Nature Medicine demonstrated that urolithin A could restore mitophagy function in aged muscle cells, dramatically improving mitochondrial quality and cellular energy production. Subsequent research has extended this finding to neuronal cells specifically. A 2019 study published in Aging Cell found that urolithin A improved mitochondrial function in hippocampal neurons and reduced markers of neurodegeneration in aged animal models. For people experiencing the effects of spinal nerve damage, the fatigue, the impaired signal transmission, the slow healing, this mechanism is directly relevant. Restoring mitophagy in nerve cells is not a peripheral benefit. It is an intervention at the deepest level of the problem. The second mechanism involves one of pomegranate's most studied individual compounds, ellagic acid. Let's look closer at how it works. Ellagic acid is a polyphenol found in high concentrations in pomegranate arils and rind. What distinguishes it is its documented ability to cross the blood-spinal cord barrier, the selective membrane that controls what enters the tissue surrounding the spinal cord. The convergence of these factors creates the conditions for the spinal nerve decline that so many people in midlife experience. Inside the spinal tissue, ellagic acid has been shown to inhibit the activation of nuclear factor kappa B, a central driver of neuroinflammation. When NF-κB is activated chronically, it drives the production of inflammatory cytokines that damage myelin and prevent healing signals from reaching damaged nerve cells. A 2018 study in neurochemical research found that ellagic acid significantly reduced pro-inflammatory cytokines, preserved myelin integrity, and improved motor outcomes. A 2021 review in the journal Nutrients concluded that its ability to inhibit NF-κB and activate the NRF2 antioxidant pathway made it highly promising for chronic neural inflammation. The NRF2 pathway is central to nerve repair. It switches on the body's endogenous antioxidant defense system, including superoxide dismutase and glutathione peroxidase. The gut microbiome plays a decisive role here. Not everyone converts punicalagins to urolithins with equal efficiency. The third mechanism involves punicic acid and its role in rebuilding the fatty membranes that surround nerve fibers. It is a vital building block. Myelin, the insulating sheath around nerve fibers, is composed of approximately 70% lipid and 30% protein. The lipid component is primarily made up of long-chain fatty acids and sphingolipids. When myelin breaks down through inflammation or compression, restoring it requires providing the specific fatty acid building blocks that the body needs to synthesize new myelin. This is where punicic acid, one of the rarest fatty acids in the human diet, becomes relevant. Punicic acid is an omega-5 fatty acid found almost exclusively in pomegranate seed oil. Research has shown that punicic acid is incorporated into cell membranes, including the membranes of Schwann cells, responsible for producing myelin in the peripheral nervous system. A 2014 study demonstrated that punicic acid increased the production of myelin basic protein, a structural component of the myelin sheath, in neural cell cultures under stress. It also reduced the rate of oligodendrocyte cell death, which is significant because oligodendrocytes are the myelin-producing cells of the central nervous system, including the spinal cord. There is one more mechanism that deserves careful attention, because without it, all the others are limited in their effectiveness. This is the foundation of flow. The fourth mechanism connects pomegranate's vivid red-purple pigmentation to one of the nervous system's most essential repair proteins. This is truly fascinating science in action. Pomegranate's color comes from a family of polyphenols called anthocyanins. These compounds are powerful antioxidants, but their most significant action goes beyond free radical neutralization. Research has shown that certain anthocyanins, and those in pomegranate in particular, stimulate the expression of nerve growth factor, NGF, in neural tissue. NGF is a neurotrophin that regulates the survival and development of nerve cells. It serves as a molecular signal that tells injured neurons to begin the repair process. Without adequate NGF signaling, nerve injury tends to become chronic rather than acute. The damage persists because the biological signal to initiate repair is absent. A 2016 study in the Journal of Nutritional Biochemistry found that delphinidin, a primary anthocyanin in pomegranate, significantly increased NGF expression in hippocampal neurons. A 2020 study in neural regeneration research demonstrated that anthocyanin treatment accelerated axonal regeneration following nerve crush injury in an animal model. There is one more mechanism that deserves careful attention because without it, all the others are limited in their effectiveness. This is the foundation of flow. There is one more mechanism that deserves careful attention because without it, all the others are limited in their effectiveness. This is the foundation of flow. Nerve tissue has one of the highest metabolic demands of any tissue. To function and repair, it depends on an intricate network of very small blood vessels called the vasa nervorum. When microcirculation through these vessels is impaired due to inflammation or elevated blood sugar, nerve tissue becomes ischemic, starved of the inputs it needs. Chronic ischemia is a primary driver of neuropathy. Even when pressure is relieved, nerves that have been chronically underperfused may struggle to recover because their blood supply is compromised. Pomegranate's polyphenols have been shown to increase the bioavailability of nitric oxide, the molecule responsible for relaxing and dilating blood vessel walls. A clinical trial in the American Journal of Clinical Nutrition found that regular pomegranate juice consumption significantly improved endothelial function within 2 weeks. If you take one idea today, let it be this. Nerve damage is not a verdict. It is a process, and every process has conditions that can be changed. Understanding the science is the foundation. Translating it into daily practice is the point of our journey today. A clinical trial in the American Journal of Clinical Nutrition found that regular pomegranate juice consumption significantly improved endothelial function within 2 weeks. Pure pomegranate juice with no added sugar is a legitimate option. A standard serving of 240 milliliters provides a comparable polyphenol concentration. Standardized extracts are useful when fresh fruit is unavailable. Look for preparations with 250 to 500 milligrams daily, standardized to at least 40% punicolagens. 1 to 2 servings daily, consumed consistently over weeks to months, is the key. The compounds work through gradual changes. Urolithin A is produced by gut bacteria when they metabolize punicolagens. The state of your microbiome determines the benefit you receive. Supporting your gut is supporting your nervous system. Consuming fermented foods and prebiotic fibers cultivates the diversity that improves urolithin production. B vitamins are essential cofactors for myelin synthesis. Vitamin B12 deficiency is a common cause of nerve dysfunction. Assess your levels if they are below 400 picograms. The pomegranate does not perform miracles. It performs biochemistry. It provides raw materials, urolithins for mitophagy, ellagic acid for inflammation, and punicic acid for myelin. Gentle, decompressive movement, swimming, walking, stretching, stimulates blood flow and BDNF release, doing more for recovery than prolonged rest. Reducing pro-inflammatory seed oils removes a direct contributor to neural inflammation. Replace refined vegetable oils with extra virgin olive oil or avocado oil. Quality sleep is when repair happens. The glymphatic system clears metabolic waste from neural tissue at peak capacity during slow-wave sleep. 7 to 9 hours are essential. Catherine was 58 when her right leg began to go numb during her commute. The numbness spread to her foot and disrupted her sleep with regularity. Her MRI showed moderate stenosis at the L4-L5 level. Her neurologist offered anti-inflammatory medications or surgical decompression as her primary options. She committed to 1 pomegranate daily, B12, alpha-lipoic acid, and daily pool walking. Ella abordó el problema directamente a nivel del nervio. Over 5 months, the burning diminished and the numbness resolved. Her clinician noted improvement that exceeded what physical therapy alone typically produced. Dr. Navindra Seeram's research demonstrated that pomegranate's metabolites cross neural barriers. He notes it is a safe strategy with a potentially significant upside. Pay attention to the smaller signals: a reduction in morning stiffness, a quieting of the nighttime burning. Learn to listen to the quiet signals. Dr. Navindra Seeram's research demonstrated that pomegranate's metabolites cross neural barriers. He notes it is a safe strategy with a potentially significant upside. These are peer-reviewed mechanisms, each pointing in the same direction. A fruit 4,000 years old finally being understood by modern science at the molecular level. Nerve cells retain the ability to regenerate axonal connections and produce new myelin even in adults well past 50. This phenomenon is called neuroplasticity. You do not need a perfect nervous system to benefit. You only need to create better conditions than currently exist, and then give your body the consistency and the time to respond. Add a pomegranate or a glass of pure juice for the next 30 days. Not as a cure, but as a signal to your nervous system that repair is possible. You do not need a perfect nervous system to benefit. You only need to create better conditions than currently exist, and then give your body the consistency and the time to respond. Add a pomegranate or a glass of pure juice for the next 30 days. Not as a cure, but as a signal to your nervous system that repair is possible. Pay attention to the smaller signals. A reduction in morning stiffness, a quieting of the nighttime burning. Learn to listen to the quiet signals. If today's video gave you hope, please share it. Subscribe to ensure this channel is part of your conversation about aging with vitality. Thank you for being here. Take care of your nervous system. It carries every experience of your life, and it is worth fighting for.